we are asked to select all of the angles for which ray HA and ray HE are sides. So we need to find HA and HE. There they are right there. So sometimes it helps to highlight it so we can actually see what angle they're talking about. So that would be this angle right here. It has several different names. We can call it by its name, exactly where the location is, which would be angle 6. We also have the points that make the angle. So we have 3 points that would make an angle. So that would be A, H, G. So that would be these 3 make that angle. And it doesn't matter the order, so we can also go G, H, A. H has to be in the center. H is the vertex or the corner, so that has to be in the center, but the other 2 can go either way. And then the same idea, we can have A, H, and then go all the way to E. A, H, E, or E, H, A. So those are the 3 there. And then we're just making sure that, like I said, the order might be a little mixed up, but H definitely has to be in the center. Okay, number 2. In the figure, we have ray CD and ray CB are opposite rays, and CA bisects angle BCE. Bisects cuts it in half. So we need to see what that looks like. And then we got, let's also make sure we read the complete question. Then if angle ECA is equal to that, so that's just follow along. And it's real important that you kind of link these together as you're doing it. So let's go back, line or ray CD. That's CD, this ray right here, and CB, this ray right here, are opposite rays. That means it's on the same line. Basically, they create a line. CA bisects angle BCE. So BCE got cut in half. That's what bisect means by this ray CA. Then they're telling us that the measure of ECA is 14x minus 2. ECA, this angle right here, is 14x minus 2. And the angle ACB is 12x plus 8. So that's 12x plus 8. Then they want ECA. They just want this one right here. So it's really important to mark these as you're doing it and then complete it with the math. So if they tell you bisect, bisect means it's cutting it in half, but it really means most often that they are equal to each other. So if this cut it in half, that means this one and this one are the same, and we use those tick marks. I also labeled it with what they're equal to. Well, they usually are giving you that information so you can use it. So that means that this angle and this angle are going to be the same if they got bisected. So I can add that angle ECA is congruent, is the same as angle ECA as ACB, angle ACB. And then there's the math for it right there. Okay, so if the angles are equal, then they're what the angles are actually equal to are equal. And then you go ahead and solve for x. I went ahead and solved for x. I got x equals 5. Now they want the measure of ECA. So ECA is this one right here. I'll take that x equals 5 and plug it in. And I get 68 is our measure. Next one. Number 3. Fill in the blanks using the available answer choices. Sanjay is designing a flag. So we have a flag here. Looks like we have some colors. If the measure of angle 2 is 108, then the adjacent angles Okay, so they're asking us, let's go ahead and highlight what they want. They were asking us to fill in the blanks using, we need to use what? The available answer choices. All right, so he's designing a flat. Got it. Measure of angle 2 is 108. So 108, they're telling us that right there. Then the measure of the adjacent angle, adjacent means next to, is blank degrees, and the measure of the vertical angle, that means across, is blank degrees. And it's real important that we can kind of do these without just guessing. We can use these options just to verify that everything has gone the way it should. All right, so I went ahead and drew it out so we can see it a little bit better. All right, so we got measure of angle 2 is 108. They gave us that information. Here's the adjacent angle. Adjacent means next to us. So there's two angles that are adjacent to 2. Angle 3 and angle 1 are adjacent. And then across from it is angle 4. That would be the vertical. Also across from angle 1 is vertical to angle 3. They're across from each other. So it's important to note that if they're on the same line, that means that they're equal to 180 degrees. So they're asking that if we have the measure of angle 2 is 108, then the measure of the adjacent angle, and there's 2 of them here, but it's the same math, is going to be what? So the 108 is right here. Adjacent to it, I'll just go ahead and look at the one to its right. So that's going to total 180 degrees. So that means to find out what this adjacent angle is, I'm going to take the 180 degrees, the total, and I'm going to subtract off the 108 piece. So angle 3 is basically what I'm going to go after. Angle 3 is 180 minus the 108, and that's equal to 72. Check. Then the measure of the vertical angle. Vertical, so that's across from it. Across from it, vertical means they're equal when they're across from each other like that. So that means this angle 4 is the same. So vertical or across are equal. So 108 is going to be the same as that, 108. And that's done. Looking at the next one, number 4. 2 angles are supplementary. Okay, so they're telling us 2 angles are supplementary. The measure of the larger angle is 12 less than 3 times the smaller angle. Okay? Then the measure of the smaller angle is what? And the larger angle is what? So we got basically a word problem that we need to translate directly. Okay, so we'll go ahead and start breaking down that information. Supplementary. Supplementary means usually it's on the same line. That's what supplementary means. But ultimately, mathematically, it means that it has to add up to 180 degrees. It's on the same line. Okay. So I went ahead and drew a picture. We have a smaller one and we have a larger one. The larger plus the smaller has to equal 180 degrees. So I went ahead and I directly translated the relationship that they gave us. 12 less than. Less than means that it's subtracted at the end of the problem, and then 3 times the smaller. So I'm calling the smaller x. It's in terms of x. That's going to be our input. So 3 times x, 3 times the smaller, minus 12. 12 less than. That's going to equal the larger. So putting that into the supplementary idea, we have the larger one plus the smaller one. That equals 180 degrees. And then we go ahead and solve. Did I solve it somewhere? I'm not seeing where I solved it. That's okay. We can go ahead and do it right now. So that's going to be, we combine like terms. It's going to be 4x minus 12 equals 180 degrees. And I add 12 to both sides, solving for x. I get 4x is equal to 192. divide by 4, divide by 4. X is equal to 4 goes into 19 4 times, so that's 16, and then there's a 3 left over. 4 goes into 32 8 times. So there's our smaller one, 48. It's our X. And then for the larger, we'll plug 48 into the relationship. So I get 3 times 48 minus 12. That's going to equal the larger. 3 times 48, 120 plus 24. 120 plus 24 is 144. If I did it right. Minus 12. That's going to be 132 equals the larger. And correct. Got it. Number 5. Which value of x? Which value of x will make the line AB perpendicular to the line CD? Perpendicular. All right. Perpendicular. Let's go ahead and just look at mine. And then we can kind of let's look at the picture first before I go into the solution. So AB, this line right here, we want it perpendicular to this line right here. And what value of x will do that? Okay. So as we look at it, we can see that this side, or this corner, is the x's. This corner is all in terms of y. So that's a distractor. We don't need that. We're looking for x. So we'll focus on the x. Perpendicular means that they're 90-degree corners. Okay? If one corner is 90 degrees, then they're all 90 degrees. The vocabulary that we use for 90 degrees is complementary. Supplementary is 180, complementary is 90. Okay? So basically, that means that this corner right here has to add up to be 90 degrees. These pieces, these angles, have to add up to 90 degrees. So angle AEF and angle FED, these two angles add up to 90. And that's the complementary idea, is when they add up to be 90. So I go ahead and plug in their pieces. They're equal to. Combine like terms. And I got x equals 9. That's all they wanted. Number 6. Fill in the blanks. Okay, we're asked to fill in the blanks. We need to use available answer choices. They're asking us to determine whether each statement can or cannot be assumed from the figure. Okay. Let's go ahead and break down each one. MTR and NTP are vertical angles. So we need to find those. As soon as you're reading it, let's go ahead and locate it on the picture. MTR, this angle right here, and NTP are vertical. Okay? So if I were doing this, I'd probably start marking it on the shape, or we can draw it again. They gave us some room. I'm just going to go ahead and jump into the solution set. Number 1. So if they're vertical, so I went ahead and drew the angles that they are asking us about, and then we're checking to see, does this look like it makes sense? So does it look like these are lines that cross and that we have angles that are across from each other? Yes, it does. Those do look like vertical, so we can assume. A lot of times in geometry, if it looks like it should be, then we can go ahead and say it is. So that's a little bit different than algebra. So we're assuming that this angle and this angle are the same. NTP and PTR are supplementary. So we'll go ahead and draw that. We got NTP and PTR, it looks like they're on the same line. Remember, that's what supplementary means, on the same line. They add to be 180, but it basically usually means they're on the same line. And yes, it does. So yes, we can assume that. Then we check out the next ones. Number 3. Number 3 says, I'll go ahead and use the drawing I have down here. QTR and PTN, do they look equal? QTR, let's go ahead and mark it. Does this angle right here look like it's the same as PTM? So does this angle right here look like it's the same as this angle right here? Okay. Now I'm just putting the double tick marks and the one tick mark because it does not look like these are the same. We cannot assume that. Okay. Visually, it doesn't look like it's the same. Cannot. Angle QTP. QTP is a right angle. Okay. Well, it looks like it could be a right angle, but for a right angle, it would have to show the right angle symbol. So it actually has to tell you, otherwise you can't assume that. So it's a little bit wishy-washy with some of these visualizations and how they are. So we would not be able to assume that this is a right angle. Okay? Even though it may look like it, it has to have that symbol, the right angle symbol. So no, we cannot assume that. Number 7. Area of a circle. What is the best estimate for the area of a circle? In square units, use approximation of pi is equal to 3.14. They're telling you to use the approximation of 3.14. Otherwise, we could not assume that we could do that. Let's dive straight in. Area of a circle. Always start off with the formula. So they're asking for the area of the circle. We need the area of the circle formula. Area of a circle is equal to pi r squared. This is something you should have on your note card or cheat sheet going into the test. So we have to count how many from the center to the edge units do we see. So I counted. We got 7. That tells us our radius. So this is our radius. From the center to the outside is 7. I plug that in. Exponents go first. Then as soon as you're done with all the math that you can do, then you plug in their estimate. Their estimate's 3.14 times 49, and I got 153.86. Matches exactly. Number 8. We're asked to fill in what? The blanks using available answers. Use the rectangle. And we're asked to round to the nearest tenth. Okay. So it looks like since this is not on the, it's not vertical and horizontal where we can't just count it, we would have to do like the Pythagorean theorem on this. So that's one way you can do it, is make a triangle to there, make a triangle there, and then you can find out what these sides are. We need those sides. We're asked for the perimeter of the rectangle, and we're asked for the area of the rectangle. Okay, we need our formulas, and then we'll go ahead and attack it. All right, so first thing you should do is mark your points, what they are, so you can see them. If you don't mark them, then you're constantly going back and you could make a mistake in how you see it. My technique is I always like to mark on the axis the values that go with the point. So this is the 0.43. So I make sure on the X I have 4 marked and I have 3 marked so I can visually see it. Do that for all your points. The area of a rectangle and the perimeter of a rectangle. Length times width is the area. Perimeter is 2 of the length sides plus 2 of the width sides, add those together, and that gives you the perimeter. It's also the distance around, so you can just add them all up. But this would be the math formula. This is two-dimensional distance, so I also have my two-dimensional distance formula. We need each side, and since it's a rectangle, it has a mirroring of the side on its other side of it. So all we really need is the long side and the short side, or the length and the width. It's important to note that length is always the longer of the two sides. Width would always be the shorter one. So this would be the width, this would be the length. Plug in our numbers. I mark them as x1 and x2, so I'm doing D1 first. Plug our numbers in, and I got square root of 20. Now, I have both of these as in my calculator. I have the square root of 20, and I kept that. That's an irrational number. It goes on forever. So here's the irrational ... and then I've approximated it to the tenths. We're never supposed to approximate until the very end of the problem. That's why my solutions are going to be a little bit different. It's because I've rounded a little too early here, but I did that to keep the math more simple for us. And luckily for us, it's not just off by a tenth. It's all these numbers are very different. So a little bit of a rounding error inside the problem shouldn't be too bad. Next one, do the same thing for D2. Plug those in. I got square root of 45. Here's our infinite decimal and our approximation to the tenths again. Once again, I should have used square root of 20 and square root of 45 here when doing the math. Let's see. Might as well just take care of it so we can see how it actually matches. Okay, so I have for the first one, so that's approximately equal to the 6.7 was approximately equal to the square root of 45. And the 4.5 was an approximation for the square root of 20. So this is really square root of 45 and square root of 20. I'm just going to do it for this one to show you, and then we'll round it. Okay, so square root of 45, square root 45 equals, okay, and I have an approximation here. It'd be a decimal. I take that number, that answer, times square root of 20. And I get 30 exactly. So this does link to 30 exactly. There's no rounding needed. And area. So be careful. I put these a little bit out of order. If we mix them up, we're in trouble. So I got exactly 30 right there. That checks out. We would do the same thing for this one right here. And then you round at the end. So it's important that you should always use your irrational numbers and then round at the very end of the problem. Okay, everything links together. And there's my little note there. I should have used the square root of 20 and the square root of 45, not these. This is just a good way to approximate, or if you're having trouble with your calculator, you can use those. And that was 7. No, that was 8. Check. 9. A construction company is ordering, let's go ahead and mark it as we go. It's ordering more yield signs to put up before starting to estimate the cost of the signs. So we're estimating the cost. The company needs to determine, so we're asked to determine the area of each sign. All right. And then they want an explanation how to determine the area of a sign. And then it wants us to, so they're asking us to explain how to determine the area of the sign. And they want us to include our calculations. Okay. Area of a triangle. It's just a normal triangle. So area of a triangle is 1/2 base times height. I called that the area of the triangle. I got 36 as a base right here. So that's the base I'm calling it. And 32 is the height. So the height is defined from the base to the tip of the triangle from the base. 1/2 of 36 times 32, and I calculated 576. These are both inches times inches, so I got inches squared. So that's how we do it. Number 10. KLM has coordinates this, and they're asked for what? So those are the coordinates of this triangle. What would be the coordinates of the vertices or the corners of the image? That's the triangle after it's been translated or transformed, after it's been transformed. And then a reflection is the transformation they're using over the x-axis. So it's a reflection over the x-axis. All right. Let's see. Where are my notes on this? All right. So for the x-axis or the y-axis, I just went ahead and dived right into it. So a lot of these will need a formula to do it, or you'll have to do it through an understanding method. So a reflection over the x-axis. So I went ahead and I graphed these 3 points. So there's our 3 points. And then I just looked at one of them. So here's point L. If I reflect it over the x-axis, it's going to be the same distance from the x-axis as the original point, so the reflection. Notice there's also a little prime right here, or an apostrophe. That represents it's the image. So that's our image. The image notation has those little apostrophes like that. Notice no, so this would be our pre-image, they call it. So before the transformation, it's a pre-image, and then after it's been transformed, it's our image. And then I went ahead and I just looked at each of these 3 points just to kind of do it. We can do the shape if we wanted to see how it's a reflection over the x-axis. Okay. So those are our 3 points. And it matches. And notice as you're doing this, make sure you note what you're looking at. That was 10. Number 11. Match each type of rigid motion to its correct visual model. Okay? So, these are transformations. I'll put it right here. Transformations, and these are a special kind of transformation called rigid. Rigid means it doesn't get smaller or bigger. That would be a dilation. All the transformations would have included a dilation. Translation. So let's go through each one. So actually, I'll just go ahead and start from top to bottom. Reflection. So notice where the flower is at and how it looks like there was a mirror in the center and it got reflected to the other side. Reflection is like a mirror. The next one right here, notice it had a direct movement up, down, left, or right, or any combination of those two. So it would have been, you could have gone to the right and could have gone down, or you could have gone down and then to the right. That is a translation. Translation, it translates directly. So up, down, left to right. And the last one is a rotation. Rotation, notice it's like the hat got rotated, like it got twisted. It twists. And then I went ahead and I wrote down the rules for rotation. Okay, so some of these we can do on paper, but it's a lot easier if we just have the formula or the rules to get through it. So for number 12, we'll go ahead and probably use the rules here. Let's see. Number 12. Quadrilateral ABCD has corners or vertices at these 3 spots, 4 spots, quadrilateral 4. Then they're asking us to find the coordinates of the image of point B after a 180 rotation about the origin. All right, so 180 rotation about the origin is one of our formulas. So there it is right there. I had to look these up. So if we rotate 180 degrees, all of these are around the origin. The X and the Y have a sign change, and a negative means there's a sign change. So coordinate B is 8, 4. So 8, 4 turns into negative 8, negative 4. If this were negative, it would have changed it to a positive. Okay? So opposite is what the negative signs mean. And there's our answer. The next one is a translation. Let's go through it. Kyle is creating a video game. Every time the main character jumps in the game, the image, it's some vocabulary, follows a translation along this vector. The main character is located at this point. They're asking us to write the new location. We want the new location after the jump. Okay? So a vector means you're adding or subtracting these numbers to your point. That moves it up, down, left, and right. The X moves it up or down, up positive, down negative. The 9 or the Y component moves it to the right positive, to the left negative. We're applying that to the negative 5, 0. So we start with our negative 5, 0 point. You're adding the 4 to the X part. That's the X part. Then you're adding the 9 to the Y part. So negative 5 plus 4, 0 plus 9. Negative 1, 9. 14. I'm going to go ahead and stop at this time, and we'll pick up on the next video.